Thank you, Yanis. So first, our coordinator, Yanis Hadjianakis, will present the project. Then our colleague Angelica will also briefly present the XR2LEARN forum. Then we will dive deep in the personalization enablers presented by our colleagues from Maastricht University, and in educational framework presented by our colleagues from Open University. After that, you will have a chance to ask any open call related questions, and then we will wrap up the session. So now I'll give the floor to Ioannis. So Ioannis, feel free to start the presentation.
Thank you, Vuk. Hi, everyone from my part. So I will go really quickly to some basic concepts, but actually before doing that, I would like to ask Angelica, who is here, to say a couple of words about our community forum, which is super important for us, and it could be also a great opportunity for you to introduce yourself and connect with the community.
Yes, so thank you, Yanis, thank you, Vuk. Welcome everyone to this info session. And first of all, we want to thank for the participation. And as we think that XR2LEARN, it's not only a project, but we are building a real community. We want to give you this opportunity to subscribe to our forum and to just 1 minute, I have someone background. Okay, so we want to give you the opportunity to introduce yourself in our forum. We think that it's important to grow and enhance our VR XR world. So what you need to do is just go on the web page, singing and register, and you will find several categories. Yanis, may I ask you to go yes, to the next slide. You can follow here welcome introduction. We will recommend you to give us a short introduction of yourself, so we can get each other known. And then you can scroll and go to general discussion. You can find several topics. There's showcases where you can meet the first winners of our project. You can go to networking. There's the possibility to ask, and then will be from our part the possibility to introduce event, webinar, and so on, and also from your side to introduce a webinar that we might be interested, and etc. So there will be thread about gaming, about technical aspect, class, possibility to have a consortium. So we can follow a lot of things, and we will thank you if you can spread the word and register, because this is a very important part of the project. And I will drop in the chat also the link, and you can scan also the QR code if you want to register. I will ask you to do it before we start the webinar, so we won't forget to do it. And also present yourself. So thank you all for your participation, and enjoy the webinar.
Thank you, Angelica. So we are going to also send you the link in the chat. It's here. So just to clarify a couple of things, there is this forum which is about the community and introducing yourselves and finding out about services of the project, but not only of the project. But regarding the second open call, which is currently open, I would like to just clarify that any kind of questions regarding the open call and all kind of clarifications regarding the process have to go through the F-Success website. So please do not post them on the forum. Do not send them to us via email. Just post them on the F-Success site so that we can answer to everyone, and then everyone can have the answer accessible. Okay, so having said that, I would just would like to add a couple of words here, and these are about the high level of objectives of the project. And the first part is essentially to connect XR designers with educational experts. We think that this is extremely important in order to develop educational material, educational applications that, of course, have a significant value. And of course, in the process, co-involve instructional designers and training organizations. These aspects are also visible in the Open Call 2 text. And in fact, we are asking you also to clearly emphasize how this will be done throughout your project's execution if you are selected. And at the same time, a second goal of the project is to deliver a digital platform. And here the digital platform is made up also by the forum that Angelica presented a bit earlier, but also in terms of models that can be used to assess the performance of XR applications. And this is a point where we would like to place a specific emphasis. And this is also the topic of today's webinar. So how can we measure essentially the value of XR that XR technologies bring to education? And at the same time, produce low-code components that will accelerate the development of XR applications and also the distribution of XR applications. So these things are encoded into the text of the second open call, but I wanted to put some emphasis. And I want to further stress the fact that we are now into this evidence collection period. So we are convinced that XR technologies are going to provide huge benefits to the education, but we need to collect as much evidence as we can. And this is where we need help from you. All of us need to work together to be able to compare, let's say, XR-based education with traditional training and then collect tangible results. And at the same time, one important element for us is also the concept of personalization. We believe that personalization will help scale educational, make it accessible to many more, make training faster and sorry, but at the same time, I need to mute people. And of course, understand how personalization can improve engagement, how it can reduce training time, and of course, understand how personalization will fit inside the educational framework, what kind of support we need to integrate personalization, which again is part of today's webinar. Now, at the same time, let's not restrict ourselves to what we are going to discuss today. There are also recordings that we have done for the 2 webinars that we organized for Open Call 1. Both of them are available on the YouTube channel of our project, where you can find information regarding the submission system, the F-Success platform and how to use it, and also the evaluation process, so that you have an idea of what we are expecting from proposal text, that is. But you will also find important information regarding the beacon applications and the enablers. So please visit the YouTube channel, but also visit the website, where you can find technical information via the wiki of the project, and of course the forum where you can connect with all the people that have developed these technologies and find out important details. That's it. I'm done, Vuk. I'll pass the floor to the educational framework.
Thank you. So the next presentation is the educational framework. It will be presented by our colleagues from the Hellenic Open University. So the floor is theirs.
Okay. Can you hear me?
Yes.
Okay. I need you to permit me sharing the screen. Is it possible?
Yes, Christopher, I'm trying to do that now. Sorry for this delay. I think you should be able to do that now.
Okay. Wait a minute. Okay. Is it okay? Can you see?
Yes, yes, we can see it.
Wait a minute again. Sorry. Yeah, okay. So, hello everyone. My name is Christopher Karachristos, and I specialize in developing learning management systems for the learning and the integration of emerging technologies in education in general. My expertise lies in designing and implementing educational learning experiences that align pedagogical strategies with ICT tools, technological tools. Today, I'll introduce you the XR2LEARN instructional design model framework, which is a practical instructional design model tailored for the effective use of XR applications in education. The framework provides methods and tools to design, develop, implement, and evaluate immersive learning experiences and learning scenarios, courses, etc., addressing the how of integrating XR in teaching. This instructional design model is a part of a deliverable of our project titled Educational Framework for introducing XR applications in education and training. So, the first thing, I'll introduce you some differences concerning educational framework and instructional designing models. An educational framework is a structured approach or system that provides guidelines to organize and support education in general. And having such a framework helps to standardize practices in achieving specific goals. On the other hand, an instructional design model is the process of creating such educational experiences and lessons and courses in a systematic way in order to make learning more efficient and effective. So there's a difference between educational framework and ID models. These things are these two things are complement each other. Where educational framework operates at a broader level, focusing on general principles, goals, and standards that guide what learners should achieve and why education matters. But in contrast, on the other hand, instructional design zooms in the specifics, answering how these goals can be achieved through well-structured methods, tools, and strategies. So some uses of the educational framework are the guiding curriculum is to guide curriculum development, the setting of educational standards, and the framing of educational policies in general. On the other hand, instructional design models are for developing lesson plans and training modules, designing learning platforms and multimedia experiences, and evaluating the effectiveness of instructional material that produced. Next, we can see an overview of our framework. As we can see here, our framework consists of 6 steps, let's say, in an iterative way. This framework is a hybrid instructional design model that bridges proven educational theories with the unique capabilities of XR technologies. And its core, the framework integrates the Azure model, a well-established and structured approach for implementing and developing courses. We are introducing here the TPAC framework, as you can see here, which ensures a balanced integration of content, pedagogy, and technology. We are going to see an example later. This combination addresses the gap in traditional design models such as ADI model or a SAM model, where we can incorporate immersive elements like 3D contents, interactive simulations, and real-time feedback, enabling educators to create engaging and effective learning experiences. Now, next we will introduce each step of the framework, and in order to do that, we are introducing here a real scenario, the designing and development of a real scenario for a high school science lesson. Science lesson on photosynthesis using VR virtual reality as a central tool. Here I have to thank Alessandra for contributing to that example. So we have here a lesson titled Understanding Photosynthesis Through Virtual Reality. The subject is biology. The grade level is high school, and the duration is 60 minutes. The scope is understanding photosynthesis. Learning objectives, we are going to see how we are developing learning objectives through our tool. The technology used here is virtual reality headsets, virtual reality simulation software, and interactive whiteboards and screens or screen to guide the class. Concerning this example, the first step here, as proposed in our model, involves the detailed analysis of learners. The analysis includes examining students' demographics such as their age, their educational level, their prior knowledge, their technological proficiency in using VR or XR tools and equipment. So in this example, as we can see, we saw that most students are familiar with basic biology concepts, but may struggle to visualize abstract cellular processes. Many are novice users of virtual reality tools, but have access to and comfort with basic technology. And we introduce here a pre-assessment where, like a quiz, in order to see their prior knowledge on photosynthesis and to measure their understanding. Some TPAC considerations here. The technological consideration here is that students need guidance on using VR headsets and navigating the software. A pedagogical consideration is that active learning models and theories and experimental strategies will help students to explore more complex processes. So we must introduce active learning strategies. And concerning the content, students must understand the stages of photosynthesis, the function of chloroplasts, and the chemical interactions involved. The next step, The next step is to state standards and objectives, establish clear learning objectives that integrate technology, pedagogy, and content, ensuring that the seamless inclusion of immersive technologies like virtual reality. We are introducing here 3 learning objectives, which is demonstrate understanding of photosynthesis by explaining how light, water, and carbon dioxide contribute to the process. The use of VR to manipulate and visualize a 3D model of the chloroplast, and the use of VR to visualize molecular interactions that are otherwise invisible. Just to mention here that in our model we are not introducing methods of developing learning objectives. Here the framework is open to use any other tool like Bloom's taxonomy in order to create effective learning objectives. The next step is the selection of media and materials for our lesson that align with learning objectives mentioned earlier, while leveraging technology's full potential, particularly for immersive experiences. So we plan to introduce here some virtual reality simulation chloroplasts to observe the photosynthesis in action. Educators here must decide which specific simulation they can use. For materials, we introduce here that we must use VR headsets for each student or pair of students, handouts with key terms and stages of photosynthesis, and interactive whiteboard for guiding the lesson and displaying the reflections. Some TPAC considerations here, technological pedagogical consideration is that the VR simulation aligns, we must ensure that aligns with the biology content, providing an immersive experience for deeper engagement. The educators should do that before in the process of designing. The next step is the bigger step. The bigger step is to implement the selected technology and resources effectively, ensuring that they are fully integrated into the learning process. So we introduce here 5 activities. The first activity is the introduction where review of photosynthesis stages focusing on light interactions and the Calvin cycle are mentioned. This activity is about 10 minutes. After that, we have a very important, for our case, step, which is the VR introduction of 5 minutes, where a tutorial on using VR headsets and software is introduced. After that, we have the VR exploration of about 20 minutes, where students explore chloroplasts, observe light absorption, track water movement, and witness glucose production. We have a group activity here, which occurs from a next step. We are going to see that, which is about 15 minutes, where small groups complete a challenge-based task where they must repair the photosynthesis process using VR observations. And finally, we have a class discussion, which is about 10 minutes, where students reflect on how VR helped them understand photosynthesis, consolidating key points on the interactive whiteboard. Some TPAC considerations here. We have the technological consideration, which is VR headsets, if VR headsets enhance tactile learning. Technological pedagogical considerations is if VR simulation integrates with the teaching strategies of active participating strategies, making learning interactive. And finally, we have the technological content considerations, which is if the simulation shows molecular interactions in photosynthesis or not. Next step is the required learning participation, which is how we can engage learners through active participation, ensuring that technology facilitates meaningful interactions with content and peers. So for this step, each student engages with the VR simulation and participates in a group challenge. We talked about the group challenge earlier. We introduced such an activity. We have challenge-based activity that choose to introduce a challenge-based activity in the VR simulation. The photosynthesis machine has malfunctioned, so students must identify errors and fix the process, e.g. adding water molecules to the right place or fixing the Calvin line. And some technological pedagogical considerations here is to ensure that learners engage with content in an immersive, active way, using technology to solve problems. Concerning this step, we ended with this instructional flow mentioned earlier, the group activity and the class discussion, etc. And finally, we have the evaluation and revision step, where we must assess both learners' outcomes and the effectiveness of the technology integration. We introduce here some formative assessment, like monitor engagement during the VR experience and ask reflective questions during the experience. We have summative assessments where with a quiz or reflection on the photosynthesis process, we can understand if they understood this process. After that, we have a revision plan, which based on the activity or the feedback and the results, we can revise the VR-based lesson and improve clarity and engagement and adjust the complexity of the simulation or group activity as needed. So this is an iterative procedure. Some technological considerations here is to evaluate the effectiveness of the VR tool in support of the learning goal objectives. Some technological and pedagogical considerations is to determine if the VR experience improved the teaching methods and students' engagement. And some technological content considerations is to assess if VR helped students visualize and understand photosynthesis better than traditional methods. And this is the whole process. After that, we just to all these things that we have developed and designed, we can, sorry, to open it. I don't know if you can see it. We can sum them here in a lesson plan where all these details, lesson title, etc., the technology used, the learnings analysis. Here we can see the state standards and the objectives of the lesson, the materials and the media needed. Here is the process with the activities, the activity flow, the activities flow, the learners' involvement, and the evaluation and the revision process. And this is the example of the application of our model. This is it. Thank you. I don't know now if we have any questions or we can answer questions at the end.
We have one question from Loreto Perez. He asked if the educational framework is in fact a beacon application.
No, it's not a beacon application. It is guidelines on how to use beacon applications and or other tools in the educational process, on how to use them effectively and integrate them in an educational scenario, let's say a lesson or a course.
Yes, and that's why it is important that everybody joins the XR2LEARN forum, because there you will find all the materials that we are talking about today. So we will send a link one more time in the chat, and everybody can, through the link, access the XR2LEARN forum containing all the materials about the educational framework, about the enablers, about beacon applications, and about guides how to use the forum and everything else. So if you want, we can save all the questions for the end, and we can now continue with the second presentation. The second presentation is the personalization enablers. It will be presented by our colleague Bulat from Maastricht University. So Bulat, the floor is yours.
Thanks, Luke. Can you hear me?
Yes, we can hear you perfectly.
All right, let me just share the screen. Can you see it now?
Yes, we can see it.
Perfect. Right. So hello, everyone. My name is Bulat, and I'm from Maastricht University in the Netherlands. And I'm a postdoctoral researcher in AI, and I work on different applications of human behavior understanding, activity recognition, emotion recognition, and beyond, using the latest AI models and neural networks. Yeah, first of all, it's really great to see so many participants here today, and hopefully not only participants, but soon to be the open call winners. So our group is one of the members of the XR2LEARN consortium, and specifically, we lead the development of AI-based personalization enablers. So today, on behalf of my team, I would like to introduce these enablers to you and also show why and how they might be used. But first, let's start with the enablers. So in our project, enablers are the components that can accelerate the development of XR applications. And there are two types of enablers that our project develops. First, you might already know the Interact, which is an authoring tool from LS Group, but also there are so-called personalization enablers. So the idea behind those is to adjust XR scenarios to users based on their engagement levels. So imagine you have a user that learns how to use certain equipment or getting trained to perform certain tasks in XR. And it would be really nice to adjust or personalize difficulty levels and training materials in a way that will maximize their learning performance. So if you see that your user is stuck, perhaps you can show them some hints, or if you can see that they are bored and everything is too easy, maybe we can provide a more challenging scenario. Well, that is actually exactly what we aim to achieve with the personalization tools. Given data that we collect from the user and some contextual information, for example, their skill level or activity level in the application, we would like to provide suggestions for personalization. Here the question is, what type of data can tell us something about user engagement? So our idea was to use the natural response of users to the tasks. Specifically, we provide tools to analyze audio signals, biomeasurements, and body tracking to decode user engagement and emotions. So such data can be actually used to train AI models within our enablers. And here for audio signals, we used data that is available in open source as a benchmark. And for biomeasurements and body tracking data, we used Magic X Room. Magic X Room is a really cool tool that our partners, also in the consortium from Switzerland, SUPSI, developed to collect and label data from specific biosensors and also VR-based body tracking and more. While developing enablers, working with these types of data, we defined a set of requirements or better say principles that enablers should cover and meet. And we made sure, for example, that that our components are standalone and that they can be compatible with different platforms. And also we support CUDA and GPUs for training the models. Yeah, there are also other principles which are on the slide. And this is the high-level diagram of the personalization enablers. While the actual personalization is only one component, which you can see on the right, we also need other tools to train, manipulate, and serve AI models to be used during the personalization. So now I would like to introduce each of them a bit closer. And also all the information that I present today is available in our technical wiki, also in the official repositories of the enablers in the GitHub of the project. And of course, you can use the XR2LEARN forum to ask questions if you have some. So let's start from the training tools. So here we provide you with the tools where you can actually train your own AI models with the collected data. And the training tools consist of multiple components. This is the actual diagram of the tool. So first we have pre-processing component. So imagine you collected the data from biosensor, and then first you need to pre-process it in a way that can be used by machine learning models or AI models. Then we also have a feature extraction modules. There are three components actually. And feature extraction is a machine learning term. So basically, how can we extract some useful information from raw data to facilitate the training of the models? And finally, the component which is responsible for model training, where we actually take this pre-processed data and use it for training the AI models. So the models are different for each type of data. So for audios, biomeasurements, and body tracking, we have different set of AI models or neural networks. But the good thing about such architecture is that if, for example, you would like to use other hardware or software to collect the data, then you can just change one of the components yourself, which is pre-processing, right? So that you can map your data to the format which is expected by other components, and then you can basically reuse all the rest. So the output of training tools is actually a trained or fine-tuned model. So it's basically just a file which contains the whole model, and it can be later used to infer the model during the personalization. So now let's talk about the inference tools. So basically what inference tools allow you to use the trained models to predict engagement or emotions in near real time. So here we also have multiple components, and here we have also pre-processing, but in this case, the pre-processing can be done in near real time. So when the data is actually streaming from the VR application, then there are emotion classification components. And here, basically, you can reuse the same models that you previously trained during the inference and actual, yeah, so like when you use the model in the VR application. So here, yeah, again, you have one model per modality, and you can use each of those. Yes, and finally, we also have multimodal fusion layer. So imagine if you want to use simultaneously body tracking and biomeasurements. This is also possible. Basically, this module accumulates the predictions of different models for the same data and provides the final prediction. So the output of inference tool is the predicted emotion. And that's what we actually use in the personalization tool. So now we can actually talk about the personalization as it builds on training and inference components. So yeah, if we have, again, the idea is that a person performs an activity in VR, and then we can collect some data and use this data and models to detect the emotion or engagement level, and then suggest the intervention into the training materials or into training scenario. So the personalization tool should be connected to the Unity application or your VR application, and also inference tool over network. And here we use Redis publisher subscriber component. And yeah, why it should be connected? Because first, it needs contextual information from the Unity application. So for example, the user level or the current difficulty or activity level. And also it uses the model predictions from the inference tools to provide the suggestion for the personalization. So if you detected that your user is, let's say, bored or doesn't like the scenario, right, or it's too easy for them, then you can perhaps make it more difficult. And on the other hand, if the user is really struggling and stressed too much, maybe you can make it a bit simpler. And these suggestions, they can be actually communicated with the Unity app. So there is a feedback loop. And in this way, the application can actually process the personalization recommendation and also adjust the learning scenario. And this part is, of course, left for the actual VR scenario and the learning scenario. So it is outside of the personalization tool. Well, there are 3 components that I already introduced, but besides them, we also provide some other components in order to make interaction with the main ones a bit easier. So first of all, we implemented the demo UI, so user interface, which is basically a web-based interface to demonstrate what is going under the hood during the model inference, so what the model predicts, and also what recommendations are given. So this tool can be used, for example, for debugging when you try to set things up or just to visualize what's going on inside. Then also, given that there are so many different components, it would be nice to have central access to them. And we also provide a command line interface for the whole, let's say, ecosystem of personalization enablers. So basically, this is just a unified entry point for users to easily access different functionalities of emotion detection. So here, for example, you can launch model training, you can launch a personalization tool, the dashboard, everything from one command line tool. Right. And finally, I would like to, again, go through how the integration can be done with the personalization enablers. So as I introduced previously, there is scenario where we also collect some data, raw data, which is passed through the inference tools, and inference tools provide the model prediction. So for example, identifying emotion. Then also Unity application should provide the contextual information to the personalization tool. So the personalization tool, based on these two inputs, can provide the recommendation. Now, these two parts in the bottom of the slide are actually a part of personalization enablers. However, the actual integration with Unity and with VR is missing. So we try to also bridge this gap by introducing a simple Unity application example that actually serves as a showcase example on how to connect personalization tool to your VR application and how you can set up the communication between these two parts of the whole architecture. So this is also available in our GitHub. This is a very simple application on how to connect to personalization enablers, and here you can provide just dummy inputs, activity level, user level, and then also see what the model recommends you, what the personalization tool recommends you, and then if you integrate such a tool in your VR application, you can actually take the suggestions of the models and try to incorporate it into the logic of your VR application. So yeah, please check this example also in our GitHub. So now I would like to conclude the talk and provide the summary of the tools that we are delivering as part of the personalization enablers. So first, we deliver the tools for training AI models. Also tools for using these models in with the near real-time inference. Then also tools for automatic personalization of user experience, dashboard that supports the visualization and integration of the enablers. Also command line interface to orchestrate the whole ecosystem, and also the application of Unity, basically the example of Unity application, where you can see how personalization enabler can be integrated with the VR, application. Now, of course, within your open call projects, you're encouraged very much to use and extend the enablers. All the enablers are in open source, so you can easily just fork them, or you can even contribute to them. So here are some ideas, but yeah, it's just a small list, and you, of course, are welcome to provide your own ideas. So first, you can use the enablers in their current form, using the current data sources to identify user engagement during the VR gaming or learning activities. Then you can also try to add a new modality. For example, can we use videos or mouth tracking, for example, to improve the performance of the models? And also, it might be interesting to explore how the personalization tool can benefit from other contextual information. So maybe you can provide also as one of the inputs the user performance in the game or in the learning scenario, or perhaps integrate the user feedback, also track the time, and then make the logic behind the, so you can basically define your own personalization logic within the personalization tool. So yeah, I guess that's it from my side. And I would be happy to answer your questions today if we have time, and also in the XR2LEARN forum. Thank you.
Thank you, Bulat. Actually, we have at least 6 or 7 questions. So if you want, I can read it to you and you can start answering one by one.
Maybe it's better if I read
Oh yeah, that's also
myself. Let me just find the first one. Okay, Angelica Marketplace. Then we will need to use the framework in our applications. Yeah, Ioannis replied. Okay, what kind of emotion classes are defined? So in the current version, we identify 3 classes: boredom, engagement, and frustration. So basically, the classes which are related to the learning, and this is based on theory of flow. So this is approach to personalization. But then in our setup in our project, basically you can define your own emotion classes and adjust the logic and the prediction of the models, and also even train the models to predict certain emotion classes which are needed for your use case. And for this, we can also provide the guidance. Okay, the next question is from Lin Yang. Emotion classification is interesting. Can I ask how you get emotion labels? So yeah, in the current so currently what we do, we use the Magic X Room. So basically, it's a application that is developed by the SUPSI. It is a partner in the XR2LEARN, and there the emotion labels are provided directly by the player. So player completes the level or the game, and then he can provide the emotion on the continuous scale with the slider. And you can also, if for example, if you want to use the same emotion classes, you can also collect your own data with Magic X Room and use this data for training. Here, the amount of work you will have to do will be minimal because all the pre-processing is already adjusted for Magic X Room format. Okay, next question is from Charlotte. Accessing the XR2LEARN community gives us access to these AI models and the ability to train our own models and share data. Well, at this point, we don't share the collected data and the models themselves, but we provide all the configs that you need to train the models if you collected it with Magic X Room. In the future, we might also consider sharing the data that we collected and also the models that we trained when we reach a certain level of performance with these models. Then question from James, surely there is a high latency for reactions to the emotions? Well, yeah, indeed. First of all, there is a natural response time of human body to the emotions, which can take sometimes up to 5 seconds. But then also, yeah, the model latency is actually it's quite low because we try to optimize the models and also implement them using the best practices. Also, you can use the GPU support there.
Doni, a ver si han pensado.
Yeah, but then indeed, so let's say that's why I said it's near real time. So it's not exactly real time, but you can imagine that you need to accumulate the data for some period of time, like 5 seconds, and then make a prediction. But then if you consider using it for long scenario, then you can actually, yeah, if one game or learning scenario takes, I don't know, 5-10 minutes, then it makes sense that you will accumulate over time and try to adjust to it. How are you collecting raw data? Question from Afonso. How are you collecting raw data in the Unity app? Any other type of hardware needed other than the VR headset? Yeah, that's a good question. So if you check the documentation of Magic X Room, actually we use some external sensor. It's called Shimmer, which also collects the skin response and heart rate. But then, for example, to collect the body tracking data, you just need the normal controllers and the headset. So we are for body tracking, we are collecting basically the positions of the head and the controllers. But I would refer you to the documentation of the Magic X Room here to get more details. Now, another question from James. So there is no working demo of the VR interface. I'm not sure if I understand the question correctly. So maybe I can share the following. So in the Q1 of the 2025, we are planning to integrate the personalization enablers with one of the beacon apps, and perhaps this can be a good example of how this can be done. But then, yeah, as I told you, we provide this Unity application, which is the module to communicate with the personalization tool from which you can start building on. Next question is from Vasilis. Could the personalization enabler be compatible also with AR apps developed using Unity? Yeah, so personalization enabler is completely standalone unit that communicates with the VR application using Redis and publisher subscriber protocol. So all the communication is done through the network. But then you just need to make sure that you collect the data correctly and then also communicate the inputs and outputs of personalization tool through the network. That's pretty much it. Next question. Are personalization enablers compatible with AR headsets as well? For example, HoloLens 2. Yeah, again, it's a standalone unit, but then for Magic X Room, you need to consult with the SUPSI and perhaps through XR2LEARN forum. So the question is whether you can actually collect the data in the same format as it is done in Magic X Room with HoloLens. As far as I know, it's possible, but again, I suggest you to check this with the partners. I'm going to share this presentation somewhere, of course. We'll share through the YouTube. Next question is from Diogo. Should enablers be developed, be provided as open source? How the open source license work? So here, yeah, we have the license information in the GitHub. So as far as I remember, we have free. So we grant the rights to use it for research purposes, but then we can also discuss this separately. If you really make use of the enablers and you want to use them in your application. Okay, I think the next question, maybe Yanis or Vuk can help. Am I correct that you expect projects applying for the open call to use these features? Is this mandatory? Yeah, Felicia can provide an answer.
Yes, of course. So using at least one of the XR2LEARN enablers is actually mandatory for this open call. It's part of our eligibility criteria. And also technology in general is one of the evaluation criteria for this open call series. I hope I answered your question.
Thanks, Felicia. Next question is about Interact enabler in GitHub. Are we not encouraged to use it? Of course, I think Anton provided the answer. And of course, you are encouraged to use even both, right? So Interact can help you to develop the VR settings with low or almost no code, while the personalization tool can help you to integrate personalization within this, the app that you created with Interact. So of course, you're encouraged to use both and also extend the functionalities and provide your own enablers. Where can I find the documentation of the Magic X Room? You can find it in the, David, you can find it in the repository of Magic X Room in the XR2LEARN GitHub. I don't know if someone can share it here in the comment. It would be really helpful. Okay, this very technology is mandatory. I don't really see it in a professional setup. Well, I think Felicia replied to this. So one of the requirements of the open call is to use the enablers. Okay, I think we are done with the questions. If there are more, please feel free to ask us. Oh. Yeah, if there are no questions, yeah, it was a big pleasure to present here, and yeah, I hope you can get the open call with your proposal. Yes, Felicia, you can.
We have one more question. There is any enabler must be used, or there is any particular one mandatory? So you can use any of the XR2LEARN provided enablers. The requirement is actually to use at least one. So you can use only one, or you can use any combination of them, but at least one, that can be any of them. Also, at this point, I would like to mention as well that we can also register to our XR2LEARN platform, and we can get access to the forum, to the technical wiki, to the software provided from XR2LEARN, and as well as another catalog of various materials, for example, 3D models. And are the answers to today's question published on F-Success? I think at some point, many of these questions has also been answered to the F-Success blog. So please, if you'd like to ask a question, check if it has been registered before on the F-Success blog, because I think we have an extended catalog of questions that we have answered there. And of course, if you don't see the question answered, you can always ask us on the F-Success blog, which is the only official means in which we can support you in the open call tool.
Thank you, Felicia.
If there is no more questions, we can wrap up this session for today. There is one message. Well, yeah, the recording does not include the chat, but it includes all the answers that were answered by our speakers today. But it doesn't include the chat. But as Felicia said, many of these questions, if not all, were already answered on the F-Success platform in the discuss section. And as Felicia said, this is the only mean of communication that we are allowed to have with the open call applicants, to ensure that the application is fair and the same for everybody. And as we already said, you can, and we urge you to register to the XR2LEARN forum, because there you will find all these materials that were presented today and many more. And also the recording of today's session will be available on our YouTube channel. So please feel free to subscribe to be able to follow and to see the recording. Also, we have the recordings of the previous webinars that were dedicated to the Open Call 1. In these webinars, we explain to you how you can how the application process works on the F-Success platform. So there you can see this information that was not presented today. You can also see this on our website on the Open Call 2 page, where we add the links to the previous webinars. We will add the link to this webinar as well there. So thank you all. Special thanks to Ioannis, Felicia, Angelica, Bulat, and Chris for presenting today. And yeah, I think we have this session.
Thank you. Good luck.
And good luck.